Okay, so in this video, we'll be discussing paper 3, Pure Mathematics 3 for October-November 2021 and the variant paper 3-1. Okay, so we start with question number 1. They want us to solve this equation where you can see that the modulus function is involved. And then they want us to give our answer into 3 decimal places. All right, okay, so we'll start with the modulus function first. All right, so I believe that there are more than one way for us to solve this kind of question. Okay, so for me, when I try to solve it, I will use the concept of the non-modulus form for a modulus function, which means that for any modulus function, right, it can be separated into two functions. One is 5 power x minus 1. The other one will be negative 5 power x minus 1. Okay, for a certain domain, for a certain value of x, right? So I'll be using this formula, separate the modulus function into this formula to get the solution. Right, so first part, I'm having 4, and then I have 5 power x minus 1. Then I let it equals to 5 power x. The other one will be 4, and then 1 minus 5 power x equals to 5 power x. Because if you try to multiply the negative inside the bracket, you'll get 1 minus 5 power x. Okay, then you just try to solve these two equations separately. Okay, so 4, I can multiply the 4 inside the bracket where I will have 4 multiply with 5 power x. You cannot straight away multiply the 4 inside the 5 and it becomes 20x. If you have 20 power x, this is wrong. You cannot straight away multiply the 4 inside the 5 because of the power of 4 and 5 are different. If the power for 4 and 5 are all both the same, let's say 4 power x multiplied with 5 power x, then you make it become 20 power x is correct. Okay, right. So when you multiply the 4 with the 5 power x, you can just keep the 4 as a constant. Then multiply with 5 power x here. Then same thing happen for the 4. You multiply into the second term in the bracket, you're having negative 4. Then equals to 5 power x. Okay, so for this particular expression here, you can try to assume that 5 power x is the y. So you're having 4y. Can you see that? This first term here is 4y. Then this one is a y. So 4y, bring the y over here, 4y minus y. Eventually, you are having 3y, which is 3 multiplied with 5 power x equals to the negative 4. I will move it to the right-hand side. It becomes a 4. And I will have 5 power x equals to 4 over 3. And then to solve this part, I will need to take ln or log for both sides. Ln or log, it doesn't matter. As long as both sides are ln or both sides are log. Okay, so you're having ln 4 over 3. Okay, and ln 5. And eventually try to use calculator to help you and get the simplified answer. Right. Okay, so if you didn't do any careless mistake in this part, your x value should be a long one. Okay, but you can cut it short into 3 decimal places where it is equals to 0.179. Okay, all right, so this is the first equation, first answer that I get from the first equation here. And now I want to proceed to the second equation. So for the second equation, maybe I will use the other color to represent it. It's easier for you to have a look. So I'm having 4 and then 1 minus 5 power x equals to 5 power x. Okay, multiply the 4 inside the terms for the bracket. So I will have 4 minus 4 multiply with 5 power x equals to 5 power x. So if you try to observe for this part, right, 4 multiplied with 5 power x, you move it over, so you have y plus 4y. Okay, so you move the 4 multiplied with 5 power x, become right-hand side. To the right-hand side, it becomes a plus, right? So 5x is a y, let's say. So 5 power x plus 4y, or y plus 4y, you have 5y on the right-hand side. So 5 multiplied with 5 power x, then the left-hand side, you're having still a 4. If you rephrase the equation, you have 5 power x equals to 4 over 5. And again, to get the value for x, of course, you need to take ln for both sides. Okay, then again, using calculator to help you. Okay, your final answer for the x that you should get is negative value, which is negative 0.139, correct to 3 decimal places. Okay, so if you want to double confirm and make sure that your answer that you get in this part are both correct, then you can try to substitute back the original long value into the equation here and see whether the value on the left hand side equals to the right hand side or not. Of course, you need to show up in the solution. But if you want it to be sure or to be confirmed that your answer is correct, then this is what you can do. You can try to substitute the original long value into the equation. Make sure that the left hand side and right hand side are having the same value. That means your answer is correct. Okay, so this is how we solve question number 1. Okay, so question number 2. We are having this expression. They want us to express 5 sine x minus 3 cos x into this form r sine x minus alpha. R is positive value and also alpha is from 0 until pi over 2. So give the exact value of R. Highlight the keyword exact value of R. And the alpha is corrected to 2 decimal places. So exact value of R means that your R can be in the third form or pi form, but it shouldn't be a long decimal number. Okay, right. So in general, the value for R and also alpha, right, there's a formula that you can straight away apply it and get the value, get the answer. Okay, so first of all, you have to double check and see our expression start with sign in front, right? And then they are changing it to sign, which is a correct matching, right? Then minus and minus, which is correct also. So now what is the formula for the R? So you might need to remember it if let's say you can't remember it for now. R is basically square root a squared plus b squared. So what is the value for A? What is the value for B? A is the coefficient for the sine x and B is the coefficient for the cos x. In this case, right? And then for the alpha, the general formula will be tangent inverse B over A without the negative sign. Right, because they are asking for the answer of alpha in the first quadrant. Therefore, for the B here, we usually ignore the negative sign. Okay, to make sure that the alpha that we get is in the first quadrant. Right? Okay, so this question is very straightforward and simple. So you can just straight away substitute the formula. So in this case, our A here is actually equals to 5, and then our B is actually equals to 3. If you want to put it as negative 3 also can, but because of for alpha, I want to get it in the first quadrant. So usually I will just assume that it is a positive value. Right, so I will start with the R. So R will be square root A squared plus B squared. So square root A squared 5 squared plus B squared. So if you didn't do any careless mistake, you should have a square root 34. And then how about alpha? So alpha will be tangent inverse B over A. So B is a 3, A will be a 5. So B over A and you get 0.54. Okay, and we already get the value for R and also alpha. Therefore, we try to rewrite again. So 5 sine x minus 3 cos x can be written as square root 34 and then sine x minus alpha. Okay, so our alpha should be in 2 decimal places. Alright, so this is how we answer part A for question number 2. So let's proceed to part B. Okay, for part B, they want us to state the greatest and also the least values for this expression, 5 sine x minus 3 cos x squared. If you can see, right, basically 5 minus x minus 3, 5 sine x minus 3 cos x appear in first part just now. Okay, so and then now for part number B, they are squaring it up. So for what I want to do now is, I will slowly start from this one. Okay, but since I know that 5 sine x negative 3 cos x, right, can be written as this expression. So I will start from this expression, slowly change it, become what they want us to get for their least and also the greatest value. Alright, okay. So just have a look for this one first. 5 sine x minus 3 cos x without the square. Without the square, okay, I will have square root 34, right? Okay, so before that, I will start with sine. Then x minus 0.54. Okay, so for the value of sine, when you are having sine x, right, you know that the maximum value is a 1, the minimum value is -1. So you can write it like this if you want. Okay, so even for sine 2x, sine x minus 45 degree, sine x minus 90 degree, right, it is still bounded between the maximum value and minimum value of -1 and +1. Okay, all right, so sine x minus 0.54, still the same, it will be bounded by -1 until +1. Okay, then after that, in my part A, I'm having square root 34. So for this square root 34, to make this inequality still correct, I have to multiply the whole inequality with square root 34. So -1 multiply with square root 34, you have negative square root 34. And then for the 1 here, you have positive 1 multiply with square root 34, so you have square root 34 as well. Okay, then after that, they want to square the whole equation here. So when you want to square the whole equation here, you want to square this center part. So beginning and also the last part here, you also need to square. So I square this center part first. If I square the center part, I will have 34. Because square root 34 square, you have 34, right? Then for the sine here, when you try to square it, you have sine square. Okay, then equals or smaller equals to, okay, so for this term, square root 34, when you square it, it will become 34. And then for the negative square root 34, right, when I try to square it, for all the negative value, when you square it, it will become a positive value, right? Okay, so when you want to write out everything in terms of the inequality, this part will not become 34, but it will become 0. So it will become, the expression is actually between 0 until square root, until 34. Okay, so why is it become 0? It is because of all the negative value will reflected up become positive. Okay, so of course the negative square root 34, when you square it will become positive 34. But if we are having, we still have some small negative value, right? So like negative 0.1, negative 0.2, when you square it, it will become positive, but it is close to 0. Alright, so if you're not so sure about this part, then basically what you can do is you can try to use a graph to help you, graphing calculator to help you. Okay, so let's have a look for sine x. So we start with the basic one first, sine x. So for sine x, right, if you have a look here, basically you can see that, oh, your graph is bounded from -1 to +1. This is -1. Your graph, the lowest point is -1. Then the highest point here is +1. Okay, but what happens if you square it? So if you have sine x, and then you want to square the whole sine x, you will see that the blue color graph appear, where the original negative part for the graph, right, will be reflected up, become positive. Okay, so as an example, if let's say just now I'm having this one as negative square root 34, so when I square it, of course, this particular value will become positive square root, positive 34. Okay, but for all this negative part here, when you reflect it up, you can see that it is a smaller value than 34. And you can see the blue color graph, right, is actually bounded but from 0 until 34, let's say okay, as an example. So you can see very clearly that when you square the sine graph, the minimum value will become a 0. Okay, and the maximum value is actually what you have when you square the maximum value originally. All right, so I hope that you can understand something from here by using the graphing calculator. Okay, so let's come back to our question here. Therefore, for this one, when I square my inequality, the square root 34 square is a 34, no problem. But for this part, for the -1, you need to imagine the graph that when you square any sine graph or cos graph, basically the minimum point will become 0. Okay, that means the whole graph will be above and equals to on and above the x-axis. Okay, therefore you have the lower limit, which is 0 actually. Okay, all right, then if you are aware, right, this particular term here, this particular term is basically have the same meaning as 5 sine x minus 3 cos x squared. So it is bounded between 34 and also 0. So what is your least value? This value will be this one, which is a 0, and then the greatest value will be 34. So usually for me, I will just write again least value is equals to 0, and also the greatest value for this particular expression will be equals to 34. Okay, so for your information, right, this question will be given 2 marks and they ask us to state. So for stating out the answer, basically the marks will be given for the final answer only. Therefore, all these are extra steps just to make you understand. Alright, so that means if you didn't really write out all the steps here, it is no problem, it is okay. But you need to know how you actually get the value for 0 and also 34. Alright, okay, so this is how we answer question number 2. Alright, so now we are now at question number 3. We are having a curve. The equation is something like this. Has one stationary point. Highlight the keyword stationary point. When you see this stationary point, means that you definitely have to apply differentiation later when they want us to find out the stationary point. Okay, find the coordinates of this point, right? So I think it's quite obvious. So the keyword stationary point tell you that you have to differentiate the equation to get the coordinate, right? So we will start from the equation here, y equals to x and then e power 1 minus 2x. If you try to observe this equation, right, basically it consists of two parts. It is a multiplication for two functions. The first function here is the x. The second function here is actually the exponential function. So when you want to do the differentiation for the product of two functions here, basically you have to apply product rule. So product rule, if you already forget the product rule, you can refer to your formula booklet on page number 3. I think it's under this part, under the differentiation part, and then this is the product rule formula. In case you already forget, right? So you can refer it here. Okay, so for me, usually I won't refer to the formula. I will just remember the process. So if I assume that x is the first bracket, e power 1 minus 2x is the second bracket, then the differentiation will be copy the first bracket, differentiate the second, then plus differentiate the first bracket, copy the second. So this is what I usually do. Okay, so I will start with my differentiation here. Okay, so to find the dy dx, I will need to copy the first bracket, which is x, differentiate the second. Differentiate e power 1 minus 2x, I will get back the e 1 minus power 1 minus negative 1 minus 2x. And after that, I have to multiply the differentiation of the power itself. If I differentiate the power 1 minus 2x, right, I will get negative 2. So I have to multiply the negative 2 at the end. Okay, so this is the process for copy the first bracket, differentiate the second. Now I want to do it the other way around. I want to differentiate the first bracket. Differentiate the first bracket, which is x. X is a 1, right? Differentiate x, you get a 1. Then copy the second bracket. So if I copy the second bracket, I'm having e 1 minus 2x. Okay, then after that, for the second step, after you found the dy dx, you need to let the dy dx equals to 0. So I will let it equals to 0. And then I try to simplify this term here. I will have e 1 minus 2x, then minus 2x, e 1 minus 2x. Okay, and then if I want to solve for this equation, right, I realize that I can factorize out the e power 1 minus 2x first. Okay, then I will have 1 minus 2x here. Okay, then I need to continue to solve these two equations to get the coordinate of the point. Okay, so I will solve this one. And another bracket will be 1 minus 2x equals to 0. Okay, so for this part, if you want to solve it, right, you have to take ln both sides. But you will realize that if you take ln both sides, ln 0 will basically give us a math error. So that means there's no solution from this part. Okay, so no solution because of if you take ln both sides, you are having ln 0 equals to math error. Okay, then come back to this part. I will get the value for the x here. So x value will be equals to 1 over 2. Okay, so you only get one value for x, which is true because in this question, they already tell you that we have only one stationary point. That means the value of x that you get from dy dx equals to 0 should be having one value only. It shouldn't be 2. If you get 2 answer, that means something wrong with your answer. Right. Okay, so when I'm having x equals to half, they're asking for coordinates, right? So I also need to find out what is the value for y. You substitute x equals to half into the y equation. So you're having x, then e power 1 minus 2, and then half. So for this part, you're having e power 0. E power 0, you get a 1. Therefore, your y is also equals to half. Okay, so from here, you successfully get the stationary point coordinate. So you can write it again. So stationary point coordinate will be equals to half and also half. Okay, so this is how we basically solve this kind of question. Right, then let us proceed to part number B. For part number B, they want you to determine the nature, yeah? Determine whether the point is maximum or minimum. Okay, so to determine whether the point is maximum or minimum, there are two methods here. The first method will be finding out the d square y dx square. And then substitute the value of x inside. And then the second value will be, you try to figure out, try to observe what is the pattern of the dy dx. Okay, before and after x equals to half. So there are two methods here. Okay, so for me, because I realized that this one, the dy dx here is a bit complicated for me to differentiate for the second time. Because if I want to differentiate for the second time, I might need to apply the product rule for one more time for a certain term here. Okay, so to me, I feel like it's too long. So I will skip the method number one. Of course, if you want to try method number one, no problem at all. Right. Okay, so I will start with method number two. So for method number two, right, basically I want to observe the value of dy dx before and after x equals to half. So usually I will tell students you can draw a table so that it is easier for you to observe the pattern. So first of all, my stationary point will be x equals to half, right? How I get the x equals to half? Just now, if I let dy dx equals to 0, then I get the value x equals to half. Therefore, when I have x equals to half, substitute it into the dy dx, you'll get a 0, right? Okay, and now I want to know what is the value for dy dx when x is smaller than half and also x is greater than half. Okay, so what you can do now is try to use a value close to half but smaller than half. So let's say half is 0.5, we can use 0.4. Okay, you can use x equals to 0.4. Substitute x equals to 0.4 into your dy dx equation, which is this one. This is your dy dx equation, right? After the differentiation, this is your dy dx equation. Substitute x equals to -4 inside this equation and observe what is the value that you get. We are interested for the sign. Is it a positive value or negative value? If it is a positive value, then you just put a positive here. So we only want to focus on the value, the sign only, all right? And then for the value that is x greater than 0.5, you can use a value more than 0.5 but close to it. So you can try to use x equals to 0.6. Same thing happen here. Substitute x equals to 0.6 into your dy dx equation just now. Try to observe and see what is the sign that you get. So by right, you should have a negative sign. Okay, right. Then after you observe all the sign here already for the dy dx, okay, so let's recall again. What's the meaning for the dy dx here? Dy dx here basically means the gradient of tangent. Okay, so gradient of tangent means that, okay, let's say if you're having the gradient of tangent equals to 0, how will your tangent graph look like? So your tangent graph will be a horizontal line, right? Okay, when gradient equals to 0, for any linear function, gradient equals to 0, you're having a horizontal line. If you're having a positive gradient, how will the linear function look like? You're going up. Correct or not? When your m is positive, so your line, when you draw the line, it will be going up like this. And then when you're having a negative gradient, you'll be coming down. Okay, so if you try to observe the value for dy dx for these three parts here, and you try to join them together, basically you will see that the curve will actually form a maximum point at x equals to half. Okay, therefore, from here, you already know that the stationary point that you get just now, right, by right should be a maximum point. Okay, so this is another alternative method that you can use to determine the nature of the stationary point. All right, if you feel that the second derivative for the dy dx that you have currently is too hard for you to continue, all right, or too complicated for you to continue, then you can consider this method. All right, so this is how we actually determine the maximum minimum point, okay, for any stationary value. All right, okay, so this is how we solve question number 3. Okay, so now we are at question number 4. Using the substitution u equals to square root x, find the exact value. Highlight the keyword exact value. Your final answer should be in surd form or high form. It cannot be in decimal number. And then when they are saying that substitution, highlight the keyword substitution also. This is actually the keyword to tell you how to start. So this is an integration question, right? So the integration technique that you are using here will be the substitution. Okay, so it is very, very obvious because they already give you the hint very clearly. Okay, so for any substitution integration, we will start from the substitution equation that they give us first. U equals to square root x. Okay, so I'm having u equals to square root x. It will be x equals to x power half, right? Okay, so first of all, start with the differentiation for du dx, the differentiation for this equation. So when you differentiate it, you will have pull the power in front become half, x, then power minus 1 become negative half. Okay, if you want to rephrase it nicely, then you will be having 1 over 2 square root x. Okay, yeah, so this is the first part that you need to do. Always you need to start like this when you are having the method of substitution integration. Okay, so after that, for this question, because I'm having the integration, the definite integral, where you can see that we are having limits here. So the value 3 here is x equals to 3. Okay, since you want to use substitution, right? So you have to try to find out what's the limit for the u if let's say x equals to 3. Okay, so this is how you can find it out. Okay, so when x equals to 3, what do you get? What's the value of u that you get? So u will be equals to square root 3. Substitute into the original equation given by the question. Okay, then when I'm having x equals to infinity, what's the value of the u? So u will be equals to square root infinity. Square root infinity, it will be still a infinity value. Okay, so once I change the limit, once I differentiate the original equation for the substitution, then I can slowly change my question. All my question now here, they are in terms of x. If you can observe, this is x, all these are the x, right? X, and dx. Before the integration, you have to change everything. All the x here become u. Okay, so we will slowly do it now. This is the original question that we have. Okay, so first of all, I want to change the limit. So from 3 until infinity, it will become square root 3 until infinity. Okay, all right. So now I observe the bracket here, 1 over x plus 1. So I'm having x plus 1 here. So how can I change the x become the u? Okay, so you have a look for the original equation. X square root x is u. Okay, therefore from this part, if let's say you know that square root x is u, that means if you want to get the x, you need to square both sides, right? So when you square both sides, you have u squared. That means in my equation here, in my expression here, 1 over x plus 1 will become 1 over u squared plus 1. Okay, then how about square root x? Okay, so what is the square root x here? By right, square root x is actually equals to u. You can change it become u if you want. But for me, right, I want to save one step here. Please have a look for this one. If I have 1 over square root x multiply with dx, what do I have? Okay, I'm having 1 over square root x dx here, right? 1 over square root x dx. And I want to change it become u. How can I change it? I can get it from this equation, from this part. Okay, if I rephrase this equation again, then I will actually have, I try to move the dx to the other side, then the 2 to this side. So when you try to change it, you can observe that you will have 2 du equals to 1 over square root x dx. So you can see very clearly that 1 over square root x dx in our equation here can be replaced by using 2 du. Therefore, I'm having a 2 du at the back. Okay, so this is how we change it, right? Okay, then now let's continue. 2 is a constant for me, right? Personally, I prefer to take it out from the integration before I start the integration. So I'm having 2 square root 3 infinity, then 1 over u square plus 1 du. So from now on, you can see very clearly that every single term or variable in my expression here is a u already, no more x. Okay, so from here you can start the integration. How can I integrate 1 over u squared plus 1? So again, if you forget how to integrate it, what you can do here is you can refer to the formula booklet again. Under the part integration, 1 over u squared plus 1. So u squared plus 1 should be something like this. 1 over x squared plus x squared. Okay, so 1 over u squared plus 1. So this is a general formula. You will get something with tangent inverse u over 1, 1 over 1. Okay, so you can observe the formula, but this formula is quite general. Okay, if can, you try to remember the detailed one, if possible. All right. Okay, so I come back to my answer here. So I know that from there, I will have tangent inverse u. So tangent inverse u. And I want to substitute in the limit for infinity and also square root 3. Okay, because they want us to have our answer in the exact form, right? So it is very important for us to decide all the exact value. Okay, now first, I substitute in the infinity inside. So you need to imagine what is the value for tangent inverse infinity. Okay, so what's the value for tangent inverse infinity? Okay, to get the value for tangent inverse infinity, you can't actually press it from calculator, right? Okay, if you try to press it from calculator, if you want to try your luck, you can maybe key in a super large value like tangent inverse 999999999, and then the answer will give you a value like 89.999999, which is very close to 90 degree. Okay, so you can try your luck by using that way also can. Okay, so if let's say you are not using the calculator to help you, then you can try to observe it from the tangent graph. But of course, you need to remember a lot of things here. Like if let's say you don't want to use the calculator, then this is a graph that you need to remember. Because you should know that for tangent graph, pi over 2, okay, and negative pi over 2 are actually the asymptote for the tangent graph. Okay, then if you try to sketch the tangent graph, you can see that this is tangent x. Okay, so you can see that when the tangent x is infinity, the value, the asymptote is actually pi over 2. Okay, so that means if I want to get tangent inverse half, you'll get the value which is pi over 2. Alright, okay, the more straightforward way will be you should use calculator to help you. Okay, tangent inverse, then you put in a super large value. You have to be large enough. Okay, so for me, I will put in a lot of 9. Maybe up to 8 or 10 times of 9, tangent inverse 9. And my calculator actually give me 89.99 something, where you can see that it is close to 90. Okay, so what is the 90 in terms of radian? So 90 will be actually pi over 2. Then minus, what is the value for tangent inverse square root 3? Okay, so for those who are using ES calculator, right, it should be no problem for you, okay, to get the tangent inverse square root 3 directly in terms of pi. Okay, but if you are using MS calculator, what you can do is you can use the calculator to find out the angle in degree first, then only you convert it into radian if you want. Okay, so that's the first option. If you don't want, then again, for those who are using MS calculator, then maybe you have to use this diagram already, the triangle, right? So when I'm having 30 degree, pi over 6 is 30 degree, then I have 1, 2, This part is square root of 3. So the opposite angle will be 60 degrees, which is pi over 3. Okay, so if I want to get tangent inverse pi over 3, my value will be pi over 3, which is 60 degrees. Okay, so if you feel that this one is very tough for you to remember it, what you can do is you use calculator to help you, but you try to find it out in terms of degree first. Then only you convert it into radian. So 60 degrees will give you pi over 3. All right, and after that, you try to simplify the whole expression here. 1 over 2 minus 1 over 3, you should have 1 over 6 if I'm not mistaken, then multiply with 2. Eventually, your final answer should be equals to pi over 3. Okay, so this is how we carry out the integration by using the substitution technique. Alright, question number 5. Part A, they want us to show the equation with cotangent 2 theta and cotangent theta and change become quadratic equation in terms of tangent. Okay, so there are many ways to solve this. So first of all, what I want to do is I will rephrase my equation here. Okay, cotangent to become tangent first. So cotangent 2 theta, I can write become 1 over tangent 2 theta. Cotangent is 1 over tangent, right? So I will have 1 over tangent 2 theta. For cotangent theta, I will get 1 over tangent theta. Then I let it equals to 2, right? Okay, so for tangent 2 theta, it is a double angle triangle. So what I can do is I can express it become single angle triangle. Single angle means that I'm having theta, not 2 theta. Okay, because my final answer should be everything in theta, right? Okay, how to expand tangent 2 theta into tangent theta? Again, if you can't remember all the formula here, you can refer to the trigonometry part, the double angle formula, which is this one. Okay, so if you can remember that, then that will be the best. Alright, so if you can't remember, you can refer it to this part. So tangent 2a, it can be written like this. And now I'm having 1 over tangent 2 theta, which means that I will have 1 minus tangent square on top, then divided by 2 tangent theta at the bottom. Then the second term I just copy, then equals to 2. Okay, the tangent theta here as the denominator very troublesome. So to make it disappear, I want to multiply whole equation with tangent theta. Okay, if you multiply the whole equation with tangent theta, and maybe I want to make the 2 disappear also, like this one, also very troublesome, right? The 2. So I multiply the whole equation with 2 tangent theta, let's say. So what do I get eventually? I will have 1 minus tangent square theta. Then this term multiply with 2 tangent theta, you have a 2. Then this one, if you multiply with 2 tangent theta, then you have 4 tangent theta. Okay, so after that, you try to rephrase your equation here. I think it's quite obvious already that you can see you get the answer for a quadratic equation with tangent theta. Okay, so this is how we solve part A. You have to apply the double angle formula, right? It is quite obvious because here you got 2 theta, and you want to express everything become theta. So by right, you should use the double angle formula to expand it. Okay, then after that, let us proceed to part number B. For part number B, they want you to solve this particular equation where you already prove it as a tangent theta equation in quadratic, right? Okay, then your theta should be from 0 until pi. That means from 0 until 180 degree. Your answer correct to 3 decimal places. Okay, so first of all, because I know that this equation has been rephrased or expressed, can be expressed become this quadratic equation. This is what we get from part A, right? Okay, so to get the theta, I can directly solve for the value of tangent theta. So for tangent theta to solve it, I can use the quadratic formula where I'm having negative b plus minus b squared minus 4ac. So b squared minus 4, a is the 1, c is negative 3, then divided it by 2a, so 2 times 1. Okay, then if you try to simplify the value here, you're actually getting two different value, which is very long. So I usually will keep it as long as possible. So the first value that you get from the calculator, right, should be this one. It's a long value. And then the second value that you get should be negative 4.645. Okay, because I know that this is not my final answer yet, and therefore, usually I will keep all the value as long as possible. Okay, although it is a bit troublesome, but I'm doing this because I want to make sure that my final answer for theta, right, will be the accurate one, will be the accurate answer. Okay, right. So first, I want to solve for the first equation first, where tangent theta equals to 0.64575 1311. 13111. Okay, so how can I get the theta? So to get the theta, you just press tangent inverse. Tangent inverse, this value, okay, in terms of radian, in the unit of radian, right, by right you should have 3 decimal places answer, which is 0.573. And the 0.573 is actually your basic angle. Okay, then again, to find out the answer of theta in different quadrant, right? Okay, so first quadrant, everything is positive. Second quadrant, only sign is positive. To get the answer from the first quadrant, you are taking basic angle. To get the answer from the second quadrant, you have to take pi minus the basic angle. So my basic angle for this one is 0.573. Then I want to decide from which quadrant do I need to consider the answer. So I'm having tangent positive. So tangent positive means that I only want to consider the answer from the first quadrant. Okay, because second quadrant is tangent negative, where I don't want. I only want the answer from the first quadrant where tangent is positive. So to get the answer from the first quadrant, the answer, this one, is basically the basic angle. And where's my basic angle? 573 is actually my basic angle. So that means this is my answer already for this equation. Okay, then after that, I continue to the second equation. Second equation, I'm having tangent theta equals to negative 4.645751311. Then if I try to get the basic angle, right? For basic angle, to make sure that it is in the first quadrant, to me, basic angle should be in the first quadrant. Right, so to get the answer in the first quadrant, when I press the calculator, I will not include the negative sign when I want to get the basic angle. Okay, then my basic angle is 1.358780807. So again, I will keep all my value as long as possible. Okay, I will keep it as long as possible so that the final answer that I get is the most accurate one later. Okay, so this is my basic angle for now, and then I want to get my answer for theta. So what is my answer for theta? Now I'm having tangent negative, right? So in which quadrant tangent is negative? In the second quadrant, tangent is negative. That means I only want to accept the answer from this quadrant here. To get the answer from this quadrant, you have to take pi minus the basic angle. So I take pi minus the basic angle that I got just now, which is 1.358780807. And by right, your answer should be 1.783. Okay, so there's only one answer within 0 until pi. Okay, so my final answer will be these two answers eventually. And usually I prefer to write out again so that examiner can see your answer very clearly. So my answer will be 0.573. Another one will be 1.783. Okay, so just double check again the request of the answer in the question. So what they want us to express our answer. They want us to express it in 3 decimal places, right? So you can see very clearly that this is actually in 3 decimal places. Okay? Yeah, so this is how we solve this question number 4. Okay, so now we are at question number 6. Right, so they give us something like this, the expression. And then they are telling us that a and b are constant, and then it is expanded in ascending power of x. then the coefficient of x and x squared are 3 and negative 6 respectively. So they want us to find the value of a and also the b. Alright, so of course we have to expand this one, right? Okay, so to expand this one, basically we can change it become the bracket with power first. So a plus bx is with power 1. And then I'm having 1 plus 4x and then power half. Okay, alright, so a plus bx power 1, right? We cannot do anything because it is power 1, so we cannot expand it further. And then when we're having 1 plus 4x power half, okay, so this one you can expand it further by using the binomial expansion formula. Right, so you can have a look here. If you can't remember the formula correctly, then it is actually provided in the formula booklet. You can have a look at this part. Right, okay, so this is the binomial expansion formula that we can apply, okay, to expand this particular bracket here. Okay, so I really tried to copy earlier just now, so maybe you can have a look here. Right, so when you are looking at the formula here, basically you need to aware that to apply this particular formula, please make sure that your first term is always start with 1. Okay, so that's the condition that you must have, right, before you can apply this particular formula here. So you can see that in our bracket here, 1 plus 4x, it is already start with 1 for the first term in the bracket. Therefore, we can straight away apply the formula for this part. Okay, then of course you need to know what is the value for n. So our n in this case is 1 over 2. And then what is our x here? Our x in this case is 4x actually. Right, so you can just straight away expand it by using the formula directly. Okay, so first of all, I just copy the first bracket first, which is a plus bx power 1. You cannot do anything with this bracket yet. Okay, then now I focus on the second bracket here. I want to apply this formula. For us, we are going to expand it until x squared, right? Because in our question here, they requested something about x squared. So we have to expand until x squared. So first term is a 1, therefore I copy it as a 1. Second term, the formula is nx, so n is half for our case, and then x is 4x here. So I'm having half 4x. Then how about the third term? So for the third term will be n minus 1. So n is half, n minus 1 become negative half, then divided by 2 factorial. Okay, then for this particular term here, x squared. X squared for us, we're having 4x, and then we have to square it. Right, so I think we just want to extend until this particular x squared term here. Okay, we are not interested for x power 3 and so on, therefore we no need to waste our time to expand it further. Okay, so first of all, we try to simplify. Okay, so by pressing calculator, I get 1 for the first term, and then for the second term, I'm having 2x, and then for this particular term, if you press calculator, you'll get negative 2x squared. Okay, and now we are interested in the term which is actually x and also x squared. Therefore, I will want to expand the term that will give me x and x squared. So for the first bracket here, a, I need to multiply it with 2x so that I will get something with the x, right? So I'm having 2ax. Okay, then for this term a, I need to multiply with this term also so that I can get something with x squared. So I'm having negative 2a then x squared. Okay, so for information, why I only focus on x and x squared? Because in our question here, they already mentioned that coefficient for x and x squared are some numbers. So I only am interested, okay, to get the term in terms of x and also x squared. So that's why for the a term, if I need to multiply with 2x and negative 2x squared to get the particular term with x and x squared. Besides the term a, I also need to consider the term for the bx. So bx, if I multiply with 1, I'll get a term in x, right? So I'm having bx. So for bx, I need to multiply also with 2x. Therefore, I'm having plus 2bx squared. Okay, so I'm not going to multiply bx with the negative 2x squared because I will get something with x power 3, where I'm not interested in x power 3. Okay, alright. Then now I try to group all the x together, all the x squared together. So end up I'm having 2a plus bx. And then 2b minus 2ax squared. Okay, so I will group the term according to the term x and also the x squared term. Alright, then after that we want to compare the coefficient. So the coefficient for x is 2a plus b, and they told us that 2a plus b should be equals to 3, because here they said coefficient of x is actually equals to 3, right? Okay, so we'll write 2a plus b equals to 3, and this is my first equation. Right? Then how about for the coefficient of x squared? So coefficient of x squared, we're having 2b minus 2a, and it is equals to negative 6. So 2b minus 2a equals to negative 6. So this is my second equation. Then I think the steps further, you should know how to solve it, how to get the value for a and b. Basically, you can solve the simultaneous equation. Right. So for a and b, I will just straight away take equation number 1 plus equation number 2, so that 2a minus 2a becomes 0, b plus 2b, b plus 2b become 3b. So you're having 3b equals to 3 plus negative 6, you're having negative 3, and therefore your b should be equals to negative 1. Okay, so if your b is equals to negative 1, then very easily, by substituting b equals to negative 1 into either a first equation or second equation, you'll get a value for a. So if you didn't do any careless mistake, right, your value for a should be equals to 2. Okay, alright, so usually for me, I prefer to rewrite my answer again. So a equals to a equals to 2, and also b equals to negative 1. Okay, so this is how we solve this question number 6. Alright, so we come to question number 7. We are given this equation, and then they want us to show that dy dx equals to expression on the right hand side. Okay, so basically we need to do the differentiation, right? So y equals to ln, and then ln x. Okay, so first of all, you need to know how to differentiate the function that involve the ln outside. You are having ln a function fx inside, right? Okay, so the general formula for the differentiation, you can refer to the formula booklet provided. So you can have a look for the differentiation here. When you're having ln x, right? So when you differentiate, you will become 1 over x. So for information, right, this is a very, very basic formula for differentiation. Okay, so if you want to actually differentiate the equation correctly, you need to know all the detail. So this is way too simple to me, because by right, you should have ln fx. So if you're having ln fx, when you want to apply the differentiation, then basically you are having 1 over fx, and then you have to multiply the differentiation of the fx. So you're having f prime x. So end up, when you want to differentiate ln fx, by right, you should have f prime x on top, then fx at the bottom. So in my opinion, this formula is actually a bit too simple, and it cannot fully show you the detailed step for differentiation. Okay. So they just show us the basic formula, but by right, you should know what is the detail of the differentiation inside. Okay, right. So for this one, let's say I'm having y equals to ln fx. Okay, so when having ln a bracket, when you want to differentiate it, you need to bring the bracket down, become the denominator. So I'm having f ln x. Okay, so after I bring the bracket down, become the denominator, I have to differentiate the thing inside the bracket. So differentiate ln x, I will have 1 over x. Therefore, when you multiply these two terms together, so you're having 1 over x and then ln x. And this is what they want us to show in this particular question. Okay, so just make sure that you understand the detailed process for differentiation. Please don't fully rely on the formula booklet here, because they don't really show you the detailed step. Alright. Okay, so let's continue to part number B. Now they are given us the they give us the differential equation, and then they are telling us some information here. X equals to e when t equals to 2. They want us to solve the differential equation, and then answer should be x in terms of t. Simplify your answer. Okay, so solve differential equation. First of all, when you're having this equation here, you need to think a way to separate the variable, all the x to one side, or the t to the other side. Okay, so before I can do anything, what I am interested to do is, maybe I want to move all the x to the other side first. Okay, so if I want to move all the x to the other side, then by right I will have negative x and then ln x. But this is not nice enough, right? Because I actually want all the dx and x together, then the dt and d together at one side. So maybe what I can do is I want to move back the negative x ln x or maybe the x ln x to the left hand side by using divided. I'm not going to plus and minus anymore, but I want to use divide. So if I use divided, right, if I do it in in detailed step, so I will have t and then x ln x dx then dt equals to negative 1. So you can see now that, oh, I'm having all the x at one side, then d I want to make it at the other side. If I want to make the t at the other side, I will move the dt here. Okay, the dt you move it over. Okay, the dt here you move it over, you will become multiply, right? So multiply negative 1 multiply with dt. And then the t on the left hand side, when I bring it over, it will become divide. So I'm having negative 1 over t. So your detailed step will be something like this. After you separate the variable, your equation will look something like this. So 1 over x dx dx, 1 over ln x, sorry, 1 over x ln x dx equals to negative 1 over t dt. You can see very clearly that now I successfully separate all the variable to two different sides here. Then you can start the integration. Okay. Alright, so now let us try to integrate the equation both sides. How to integrate 1 over x ln x. Okay, so we need to refer back to our first part. You can have a look at when I'm having y, it is equals to x ln, it is equals to ln x. When you differentiate, it will become 1 over x ln x. So that means if you want to integrate 1 over x ln x, you have to apply the opposite process, right, which is integration. So that means when you want to integrate 1 over x ln x, you should get the original equation of y, which is ln x. Okay, so that's the purpose of why they want us to prove the differentiation result, because we can apply the result straight away in our part B that involve the integration. Okay, so integrate 1 over x ln x will give you ln x. All right. For the left hand side here, I can directly write ln and then ln x. So I don't want to write any constant term on the left hand side. I want to group everything on the right. So I don't have any plus c here. Okay, therefore this one I'm having integrate 1 over t. You should have negative ln t and then plus c. Okay, so this is a general solution after you solve the differential equation. Now I need to get a particular solution to find out the value for c. How to find the value for c? You can use the information given here, x equals to e when t equals to 2. Okay, so I will start the substitution when t equals to 2 and also x equals to e. Substitute it into your equation here. I'm having ln e, then negative ln 2 plus c. Okay, then slowly figure out the value here. Ln e equals to 1 and then ln 1 equals to 0. So you should have a 0 here equals to negative ln 2 plus c. And this gives you the value of c, which is equals to ln 2. Okay, so now you can rewrite your particular solution here. Ln x equals to negative ln 2 plus ln, ln t plus negative ln t plus ln 2. Okay, so by right, this is your particular solution already. And now they want us to express our answer x in terms of t. So we have to group all of them together. All the terms here in my solution, right, I'm having ln. Therefore, to make the ln disappear, what I need to do is I have to combine all the ln together at each side. So ln 2 minus ln t will give us the equation ln 2 over t. Okay, because we are using the concept of what ln p minus ln q can be simplified as ln p over q, right? Yeah, so we are applying this on the left hand side here. Oh, sorry, on the right hand side here. Okay, from here to this part, we are using this. Okay, and after that, you realize that both sides I have also one ln, right? So at this stage, you can cancel both ln, the ln at both sides. So your equation now become ln x equals to 2 over t. Okay, further simplify it, I want to bring the ln over. Ln is exponential e, right? So the 2 over t will become the power. So I'm having my equation x equals to e power 2 over t. So this is my particular solution where I express the equation x in terms of t. Alright, okay, so now let's proceed to part C. Okay, so for part C, they want you to state what happened to the value of x when t tends to infinity. Again, I try to write the equation again. Our solution is x equals to e power 2 over t, right? Okay, so now they are saying that t is infinity. What happened to the x? Okay, right, so let's have a look. If I'm having t infinity, right, so 2 over t will give you the value 0 because 2 divided by a super large number. Okay, substitute t. You assume that t is a super large number. So 2 divided by a super large number, it will give you a very, very small value where we can assume that it is equals to 0. It approached to 0. Okay, so if let's say 2 over t is approached to 0, right? So what happened to e power 2 over t? That means you're having something like e power 0. So for e power 0, basically you're having a 1. Because you can have a look for the graph of e. Okay, so this is a graph of e power something, e power x squared whatsoever. Alright, so when you have x equals to 0, e power 0, it is always equals to 1. It will pass through the 1 here. Okay, so e power 2 over t will give you a value of 1. So that means if e power 2 over t give you the value close to 1, that means x is also having the value close to 1. So you can write x is approach to 1. Alright, so for this question, they just want you to state the answer. What happened to the value of x? Also, you can tell them that x approached to 1. Okay, but of course, if you want to have a look for the detail, that means you try to substitute t equals to infinity, which is a very, very large value, into your equation, and see what is the final answer that you get. Alright, okay, so this is how we solve question number 7. Alright, so question number 8. The constant a is such that they give us this equation that involves integration, and then they want you to show that a equals to exponential with the power 1 over square root a plus 2. This is a power, so you are having e power this one. Okay, so if I want to get a solution, I want to get this equation, a equals to something else. Basically, I think we need to solve this particular integration first. This is the information that they give us to start with. Alright. Okay, so let's have a look for the left-hand side for the equation. It involves integration, right? So first of all, you need to know what is the correct technique for you to apply this integration or to find the answer for this integration. Okay, so it is not substitution because if it is substitution, by right, the question will give us some keyword about use the substitution or something else, right? So it is not substitution. So for this fraction, we are having a fraction here. So you can try to observe and see whether are you having the fraction with this pattern on f prime x over fx or not, which means that if you let the denominator become the fx or square root x become the fx, when you differentiate it, will you get something on top? So when you differentiate square root x, definitely you won't get log x, right? Okay, so definitely you won't get log x. Therefore, this particular question here also does not belong to this one. So it is not substitution. It is not f prime x over fx pattern. Then what we can consider is, if you have a look for this one, you can try to think about it is actually the product of two different functions, which means that I'm having first function, which is 1 over square root x, and then the second function is log x. So it is something multiplied with something. You're having the product of two different functions. When you are having the product of two different functions and you want to integrate it, you can try to consider integration by part. Okay? Alright, so from here you can slowly identify what is the suitable method for you to use right, in integration. So now, since we know that it is a product of two different functions, we are going to apply integration by part for the integration here. Okay, so what's the integration by part formula? So again, if you can't remember, then you can have a look for the formula booklet. It is provided here, this one. Okay, alright, so again, I already tried to copy just now, so let's have a look for this particular formula. Okay, so for me, right, this formula looks complicated. Therefore, when I discuss, I will always ask the students, you can cancel off the dx and dx. because originally these two are dx, right? So usually I will tell students, if can you try to just ignore them now. So that means I will tell students, don't look at the dx and dx here. So your equation will have u dv, and then this part also the same. Okay, so this part also the same. You try to cancel out the dx with the dx. Therefore, equation is something like v du. So for me, usually when I discuss this with students, I will use the formula where integrate of u dv equals to uv minus v du. Okay, all right. So this is the formula that we get from the formula booklet, and of course, you need to know the detail. All right, so for the detail here, at first, in your original question, right, you need to know which one is the u, which function is the u, and also which function is dv. Okay, so we are having the Liates rule, Liate. So I hope that you still remember about this rule. When your function is at the higher part, it belongs to u. And then when your function is a lower part, then it will be in integration of dv. Okay, right, so L means logarithmic function, I means inverse trigo, A means algebra, T means trigo, and also E means exponential function. Okay, so just recall back again. Alright, so we are applying the LIAT rules here. So the higher group will be the L, the lower group will be the E. Okay, alright, so now let's come back to our question here. We are having 1 over square root x multiplied with ln x, right? Okay, so for ln here, ln x belongs to log function, right? So it's L, belongs to the group L. And then this one, 1 over square root x, belongs to algebra, which is A. So you can see that group L is at higher group, and then A is at the lower group. Therefore, for integration by part, you will let u, the higher group will be the u, right? So you will let u equals to log x. Okay, where the integration of dv will be equals to what? Will be equals to this one. Okay, so you're having integrate of 1 over square root x dx. So this is how we decide, okay, or we determine which group is which one. Alright, okay, so after you decide the u and also dv, then of course you can start with the integration and differentiation now separately. Okay, so for 1 over square root x, I want to straight away change it become x power negative half, easier. Okay, so for this part, you are going to apply the differentiation. So du over dx equals to 1 over x. Differentiate ln x, you get 1 over x here. Okay, and then maybe what you want to do is maybe you can let it like this, du equals to 1 over x dx. Okay, so for this part, integrate dv, basically it is integrate 1 dv. Integrate 1, you get a v. Okay, so integrate this part, you will have x power plus 1 become half divided by the new power half. So by write your v, after you simplify, you should have 2 square root x. Okay, there's no more plus c here first, because this is not the final answer yet. We will put a plus c after we complete our integration step, right? Okay, so after you carry out the initial steps here, determine the u and also dv, then now you can start to apply this formula here. So this part basically is your question. So this is my question. And then this part will be after integration. Okay, what is your equation here? What is your answer, right? Okay, so I will start from our question here. This is the original equation provided by the question. So we can start from information here. Okay, so I'm having integration of 1 until a. Then we are having ln x divided by square root x dx, that equals to 6. Okay, so this one, now I want to replace it by uv minus integration of v du. Okay, remember this equation now, uv minus integration of the v du. What is uv? U is ln x, right? So I want to put in ln x multiply with v, u and v. This is my u, ln x, and then what's my v? V is this one. So you multiply it with 2 square root x, and don't forget to substitute in the limit a and 1. Okay, After that, minus. So minus what? Minus integration of v du. So integration sign you just copy. Also included the limit 1 under a. Then they're asking for v du. So what is my v? V is 2 square root of x. What is my du? So my du is this one, 1 over x square root of x. Oh, sorry, 1 over x dx. Okay, and this whole thing will be equals to 6. So this whole thing is the left hand side, and it is equals to 6 on the right. Okay, then now we can slowly substitute in the value here. Substitute a into this equation. This expression I'm having 2 square root a multiply with ln a. Substitute 1 into the equation, into the expression. Ln 1 is a 0. So 0 multiply anything also 0, right? So you can put it as minus 0. Then for this part, what am I going to do is, I usually prefer to factorize out the constant before the integration. Square root x divided by x, end up you're having 1 over square root x, which is x power negative half. And then it is equals to 6. Okay, then continue further. The first term here, I have settled it, so I just keep it as 2 square root a ln a. I don't do anything anymore. Just copy it. Okay, then for this part, I can integrate it. Negative 2, I just copy. Integrate x negative half. Power plus 1 become positive half. Divided by the new power half. And then substitute the value a and 1. It is equals to 6. Okay, so next step. I want to factorize out the 1 over 2 at the denominator. When I factorize it out, eventually I'm having a 4 here. Okay, so x power half is square root x, right? So substitute a into the x, I'm having square root a. Then minus, substitute the 1 inside, I'm having 1. Square root 1. Square root 1 is still a 1, right? Okay, that equals to 6. Then now I can slowly simplify my answer and see, can I get what they want us to prove or not? So expand the 4, the negative 4. Okay, according to the equation here, I'm having something plus 2 in the bracket. So maybe I can move the 4 to the other side. So maybe what I have here is 2 square root a ln a minus 4 square root a equals to 2. 6 minus 4 equals to 2. Okay, and then you can simplify all the whole equation by 2. Alright, and then what else can I simplify further? What else can I continue? Where can I continue further? Right, so you can factorize out the square root a. I'm having ln a minus 2 equals to 1. So ln a minus 2 equals to 1 over square root a. Ln a equals to 1 over square root a plus 2. So you can see slowly your answer is actually, you are getting closer and closer to the answer. So a equals to e power 1 over square root a and then plus 2. Okay, or you can just write as exp, exponential function with the power 1 over square root a plus 2. They are the same actually. Alright. Okay, so this question, to prove the equation that they want us to show, it will be slightly longer because at first you need to decide what is the correct integration technique first to lead you to this answer. Alright. Okay, so for this particular question, we actually apply integration by part. Okay, then now let's proceed to next part. Part B. So for part B, they want you to verify by calculation that A lies between 9 and 11. Okay, so again, I rewrite my function again. My function just now they want us to prove is A equals to E power 1 over square root A plus 2. Okay, so this is the equation that we get just now. And now they want us to prove that the A lies between 9 and 11. So to prove that A is between 9 and 11, right, basically I will use sign change method. So to use the sign change method now, what I need to do is I have to actually move all my variable to one side. So that means I have to move the a to the right hand side. So my function a will become 1 over square root x, e power 1 over square root a plus 2, and then minus a. And now I want to substitute in the value 9 into the function, and also I want to substitute 11 into the function. If you see the sign change in F9 and F11, that means the roots lies between 9 and 11. So try to press calculator. So if you want, you can try to press calculator here. Your equation is this one, right? So you can press e power 1 divided by square root x or square root a, but we just write as x, okay? Then plus 2, close bracket, okay? Then minus x or minus a. Okay, so this is my original equation here, okay? And now I want to substitute in 9 into the function. So you press calculate and then 9, then press equal sign. So they will give you 1.31. Therefore, your answer is 1.31 here. How about if I want to substitute the value 11? So press calculate again, then press in the value 11 and equal sign. Then you get negative 1.01. So I'm having negative 1.01 for this value. So you can try to observe to see F9 and F11. One is positive and one is negative, right? So this is what we call a sign change. So when you see the sign change, that means the root actually lies, the A lies between the 9 and the value 9, 11. Okay, so you can say like these are a simple conclusion and reasoning. Sign change can be seen, okay, between F9 and also F11. Okay, therefore you can tell them that A lies between 9 and also 11. Alright, so for me, I'm using sign change method to show, okay, that the value of A actually lies between 9 and also 11. Okay, but of course, you need to make sure that you move all your variable to one side and make it become a function fx or fa first. Okay, then continue further for part number C. For part number C, they want us to use the iterative formula based on the equation in part A. So again, my iteration formula is the original equation. A equals to e power 1 over square root a plus 2. Okay, so to determine A correct to 2 decimal places, give the result for iteration to correct to 4 decimal places. Okay, so I want to find the value. You need an initial value to start with. Alright, so again, what is the initial value? In this question, they didn't provide us the initial value. You can actually substitute any values, but you can refer to this one because you know that your root is between A, 9 and 11. That means your initial value, you can use any value that's close to these two numbers. Okay, then it's easier for you to get the answer by using the iteration formula. Alright, okay, so since I know that it is between 9 and 11, so maybe I want to take the center value. So I will take my initial value as A1 equals to 10. So how to get the second value? To get the second value, right, basically you substitute your initial value into the iterative formula. So 1 over square root 10 plus 2. And then see what will you get when you press the calculator. So again, I will want to reset my calculator, my formula one more time. Okay, so I'm having E. So shift long power 1 over square root x. So 1 over square root x, then close bracket, plus 2. Okay, so please take note, now the equation iterative formula is the original formula on the right hand side only. Okay, right, then again, we repeat the same step just now. Press calculate. Your initial value is a 10, right? So put in the 10 and press equal sign. You'll get 10.1374. They are asking us for the iteration correct to 4 decimal places, right? So please make sure that you write out the answer until 4 decimal places. Therefore, I'm having 10.1374. Okay, then after that, you repeat the same step. Substitute this value into the equation again to get the A3. So you can repeat this by using calculator purely. So you can press calculate. Then they are asking what is the value for x, so you just key in 1374. Okay, then you press equal sign. So the next value, the next iterative formula will be iterative value will be 10.1156. Okay, so equals to 10.1156. Okay, so next value again. Repeat the process one more time. Press calculate, then key in 10.1156, then press equal sign. Then you get 10.1190. So 10.1190. Okay, so there are a lot of students, they will ask, when should we stop? So you should stop when you're having two decimal places answer repeated. Okay, so we can have a look for this one. If you have a look for this one, right, two decimal places number should be 10.14. Then for this one, it will be 10.12. This one also 10.12. So by right, you can see 10.12 is repeated twice already, right? So by right, you can actually stop here and write your answer as 10.12, correct, to two decimal places. But usually for me, I want it to be safer. Usually I will want to carry out maybe one more or two more extra iteration. So again, I press calculate one more time, then I will get 10.1190. Then you press the equal sign. Then you get 10.1185. 10.1185. Then again, I try to investigate the two decimal places answer. This is also 10.12. So you can see very clearly that 10.12 already appeared for so many times, repeated for so many times. Then I can write here the root a, which it will be, or maybe you can write it as a root up, or the value of a should be equals to 10.12, correct to two decimal places. This is requested by the questioner. They are asking for the answer correct to two decimal places, right? Yeah, so when you try to find out the root, when you want to show all the iterative value here, please make sure that you show all your iteration correct to 4 decimal places. Okay, right, so this is how we answer question number 8. Okay, so let's discuss question number 9. We are given two lines, right, M and L. Then these are the vector equations given. So they want us to show that L and M are perpendicular. So to prove that the lines are perpendicular, basically you need to show that the direction of the line, when we take the dot product for direction of the line, it should be equals to 0. So as example, if let's say I'm having the direction of the line for L, okay, then dot product with the direction of the line for the M, and they should be equals to 0. If let's say we get the value equals to 0 for the cross product, that means they are perpendicular to each other. So they want to show that these two lines are perpendicular. Therefore, we have to take the direction of the line. So which is the direction of the line in the vector equation given? So basically, in the first line here, the first vector equation, the vector in front is actually the passing point, and the direction of the line is actually the direction at the back. Okay, so the 4, -1, and 3 is the direction of the line L. And then the direction of the line M will be -1, 2, and also 2. So I'll be taking these two directions, 4, -1, and also 3. Then I want to have the dot product of that. So which is -1, 2, and also 2. So when we calculate the dot product for these two vectors, right? So you take the x component, multiply with the x component. So 4 multiplied with -1, you get a -4. And then plus, the next one is you take the component y, multiply with component y. So -1 multiplied with 2, you get -2. And the last one also the same. Component z, multiply with component z. So 3 multiplied with 2, you get 6. So when you try to simplify all this value together, you'll get a 0. Alright, so when you get a 0, it means what? It means that the line L and M are perpendicular to each other. So you can write a simple conclusion where line L and M are perpendicular to each other. Okay, so this is what we have for part A. Then let's continue to part number B. They want us to show that L and M are intersect. and they want us to show the position, state the position vector of the point of intersection. All right, so to find out the intersection point or to prove that the line L and M are intersect with each other, basically you need to like solving the vector equation simultaneously, which means that I will try to write the vector equation of L in a vector form and also the vector equation of M in the vector form. So in the vector form means that I combine them in a column vector, which means that I will have 3 plus 4s for the x component of line L. So you're having 3i, right? And then plus 4s, right? 4si. So I write as 3 plus 4si, like this in a column vector form. And then for the y component, it will be 2 minus x, 2 minus s. And then for the z component will be 5 plus 3s. It is equals to, okay, then the vector equation for the line M. I'm having 1 minus t, then negative 1 plus 2t, and also negative 2 plus 2t as well. Okay, so just like when you want to solve the simultaneous equation, we want to solve the simultaneous equation from this, okay, these vectors. And then basically we're having 3 different equations here. 1 equation from component x, 1 equation from component y, and also 1 equation from component z. All right, so you can solve to get the value for s and t by solving any of the 2 equations from the vectors. All right, so as an example, maybe what am I going to do is I will want to use this one. Maybe I want to use this equation here where I will get 2 minus s equals to negative 1 plus 2t. And then I will keep 2t as the main object here. So I will have 2t equals to 3 minus s. So I will use it as first equation. And after that, for the second equation, I might want to use the last one, the component z. Because here I can observe that I will be getting 2t also, right? Okay, so I'm having negative 2 plus 2t. Therefore, I want to keep it as 2t equals to 7 plus 3s. So by using these 2 equations here, I want to solve them simultaneously to get a value for s and t. Okay, so from here, to solve them simultaneously, I will have 3 minus s equals to 7 plus 3s. All right, then if I try to solve it, I will have s equals to negative 1. So when I get s equals to negative 1, right, then I can also get the value of t by substitute the value of s into either equation number 1 or 2. Then if you didn't do any careless mistake, by right you will get the value t equals to 2. Okay, so after you get the value for s and t, right, to make sure that or to prove that they are intersect but not skewed, you need to substitute these 2 values that you get, substitute it back into one of the equation that you never used just now. Okay, so for me, for our case here, for our example here, what we are going to do now is I will substitute s equals to 1, s equals to negative 1 and also t equals to 2 into the x component equation. Okay, so into 3 plus 4s equals to 1 minus t. So I want to check the value for the left-hand side and also the right-hand side. So if I substitute into the left-hand side, I'm having 3 plus 4s. So s is negative 1. Right, then the value that I get is negative 1. Then after that, I want to check the value for the right-hand side. So the value for the right-hand side is 1 minus t. So it will be 1 minus 2. I will also getting negative 1 for the right-hand side value. So from here, you can check that left-hand side value equals to right-hand side value. Then it means that the line L and M are intersect with each other. How about if we are having the case where the left-hand side value is not the same as the right-hand side value? If let's say left and right-hand side value are not the same, basically the line L and M are not intersect, but they are skewed. We're having the other case for the 3D lines, right? So if let's say they are not the same, that means they are the skewed case. Okay, but if the value for the left and also the right-hand side are equals to each other, that means these 2 lines, basically they are intersect to each other. So this is an important point or important step that you need to show to show that the line are intersect. All right, and they are not skewed. Okay, after that, they want us to state the position vector of the point of intersection. So to get the point of intersection, we can substitute s equals to -1 or t equals to 2 into either one of the vector equation that we have. Then by right, the vector that you get will be the position vector of the intersection point. Okay, so maybe I'm using this the other color here. Okay, so to get the position vector of intersection point, okay, so either one, you can substitute s into the first equation, the vector equation for the L, or t equals to 2 into the vector equation of the M. Right, either one. So maybe for me, I will want to substitute into the vector equation of line L. So 3 plus 4s, s is -1, and then this is the component I, right? Okay, then plus j will be 2 minus s, where I will be having 2 minus -1, then j, and after that, for the component z, it will be 5 plus 3s. So 5 plus 3 with -1, and this is the component k. Then I try to simplify all the value here, and the vector equation that I get here will be equals to, oh sorry, not vector equation, the position vector of the intersection point will be -1, I, 3j, and also plus 2k. So basically, this is the position vector of the intersection point. Right, so this is how we solve part number B. And let's continue to part C. Okay, so for part C, they want us to show that the length of the perpendicular from the origin to the line M is this value. Alright, so let's talk about the perpendicular distance, the length of perpendicular. Let's say I'm having the line M here. This is the line M. Okay, and the line M is having the vector equation, where if I write into a column vector form, right, this is the vector equation of line M, given in the question just now. And for this part C, they are interested to find out the length of the perpendicular from origin to the line M. So let's say my origin is this one, and the origin, the position vector is 0, 0, 0. And then to get the perpendicular distance, right? So I will label this as F, the foot of perpendicular. So that means they are interested to calculate the length, okay, from O, the length of the vector OF, in short. Okay, where OF and also the line M are perpendicular to each other. Okay, so our aim is to find out the D, where the D is the length of OF. So this is a perpendicular length or perpendicular distance from the origin to the line M. Okay, so first of all, to find out the length of OF, I need to know what is the vector of OF first. Okay, so for your information, since the point F, right, lies on the line M, therefore the position vector of F is equals to the vector equation of the line M. Okay, so this is a small knowledge that you need to know. When we are having any single point that lies on a certain line, okay, so the position vector for this particular point is actually equals to the vector equation of the line. Therefore, if I want to know the position vector of F, basically it will be equals to the vector equation of the line M. So I will write it in this way, where it will become 1 minus mu. Okay, instead of using t, I will use it as a mu, where mu is the particular value that when you substitute into the vector equation here, you will get the position vector of F, right? Then for the y component will be -1 plus 2 mu, and also -2 plus 2 mu as well. So this is my position vector for OF, for F. Okay, then after that, since I know that the vector OF is perpendicular to the line M, therefore, I know that if I take the position vector of F which is a vector, right? Multiply with the direction of the M, the line M, it should be equals to 0. Because this vector and the direction of the line, they are perpendicular to each other. So I'm having this, which is OF, dot product with the vector with the direction of the line M. Direction of the line M is this one, -1, 2, and 2. Okay, I let it equals to 0 because I know that they are perpendicular to each other. So and when I try to apply the dot product for these two vectors, I'm having mu minus 1, then minus 2 plus 4 mu, then minus 4 plus 4 mu equals to 0. And from here, if you try to simplify the equation here, you'll get the value for mu. So the value for mu is actually 7 over 9. Okay, so once you get the mu already, then now you can substitute the value of mu back to the position vector of f. If I substitute mu into the position vector of f, then I will get the value of the OF, right? So now I substitute it into the OF equation, the OF vector. So 1 minus mu, I will get 2 over 9. Okay, then the y component will be 5 over 9, and the z component will be -4 over 9 after you simplify that. And since we are interested to find the perpendicular distance or perpendicular length, okay, of this particular line, right? So it is actually the modulus or the length of this particular vector, right? So the length d is actually the length of the vector OF. So to calculate the perpendicular distance, okay, so basically it is actually the modulus or the length of OF vector, the vector OF. Therefore, you just need to try to find the length of it. So it will be 2 over 9 square plus 5 over 9 square plus -4 over 9 square. Okay, so if you try to simplify everything here, you have square root 5 over 9. And of course, square root 9 can be simplified, become 1 over 3. And therefore, you are having the answer that they want us to show, where it is equals to square root 5 over 3. Alright, so this is the suggestion how we actually solve this particular question here. To find the perpendicular length, right, there are many different ways. So for me, this one is a method that we can see clearly step by step. And what are we doing actually? So the first one, we try to form the position vector of the foot of perpendicular. After that, we know that the vector here and also the direction of the line are 90 degrees to each other. Therefore, when you apply dot product to them, it is equals to 0. So from here, you get the unknown. Substitute the unknown back into the position vector equation. You'll get the vector, and then you can use it to find the perpendicular distance, which is the length of the vector itself. Alright, okay, so this is a suggestion how we try to find the perpendicular length from the certain point to the line in the vector form. Okay, so this is how we solve question number. Okay, so we are now at the last question for this paper. The complex number 1 plus 2i is denoted by u, and then we are having a polynomial. It denoted by px. Okay, so it is given that u is a root of the equation px equals to 0. They want us to find the values of a and also the b. Okay, so since they tell us that u is a root of this equation px equals to 0, that means if we substitute the u inside our x here, basically we will get the value 0, right? Then we can try to use this information, okay, to compare the real and the real part, imaginary with the imaginary part in the equation or the polynomial, and to get the value for it. Okay, so this is what we have, what we can get from the information given. So we try to have px equals to 0 first. Okay, so if px equals to 0, and since u is the root, right? So I will have 2, and then x power 3. The x, I will substitute it by using 1 plus 2i. power 3, then plus a 1 plus 2i square, okay, plus 4 1 plus 2i plus b equals to 0. Okay, so we are interested to know what is the value that we have when we expand 1 plus 2i squared. So if I expand 1 plus 2i squared, right? If I expand it slowly, I will have 1 plus 2i plus 2i plus 4i squared. And then 4i squared is negative 1. Okay, so this one, I squared is negative 1. Therefore, I'm having 1 minus 4, where eventually I'm getting negative 3 plus 4i. Okay, so that means if I substitute and continue my calculation here, right, 1 plus 2i cubed, I will have 1 plus 2i squared multiplied with 1 plus 2i. So 1 plus 2i squared under this part, I will write it become negative 3 plus 4i, multiply it with 1 plus 2i, power 1. Okay, cube, so that means just now we have a square, 1 plus 2i squared. I substitute this result into here, and then continue to multiply with another remaining 1 plus 2i. Okay, then plus a, I just copy. Again, 1 plus 2i squared, I can substitute in the value negative 3 plus 4i. Then the value at the back, I can try to expand them slowly. Okay, so next step, I need to expand these two brackets again with the complex number. I'm having negative 3 plus, negative 3. Then negative 3 times 2, I have negative 6i. Then plus positive 6i. Then minus 8. Because I squared is negative 1, right? So 4 times 2 times negative 1, you are having negative 8. Then for this part, I try to expand what I have here. Substitute in the a, multiply the a inside the bracket. So this is what I have. And I'm having plus 4 plus 8i plus b equals to 0. Okay, so throughout this whole part, you just need to make sure that you don't do careless mistake. Okay, then next one, I will continue to multiply this value. Negative 3 minus 8, I have negative 11. So negative 11 times 2, I have negative 22. Negative 6 plus 4i, negative 6i plus 4i, I have negative 2i times 2, I have negative 4i. Okay, then negative 3i plus 4ai plus 4 plus 8i plus b equal to 0. Okay, so what am I going to do now is I will try to collect all the real term. Real term means without the I one all together, and also group all the imaginary part with the I one all together. So without the I, I'm having negative 22, negative 3a plus 4 plus b. So when I write all of them together here, I will have, let me highlight it. Negative 22, negative 3a plus 4 plus b. So I simplify all the yellow highlighted part. I will have b minus 3a, negative 22 plus 4, I have negative 18. After that, I want to group all the imaginary part, negative 4i plus 4ai plus 8i. So if I try to group them together, right, basically what I have here is I will have 4a, then negative 4 plus 8 is plus 4, right? So 4a plus 4, then with a bracket I equals to 0. So you can see that I group all the real part together, all the real term together, all the imaginary part together. Okay, then now, since I know the right hand side is equals to 0, right? So that means the real part equals to 0, imaginary part also equals to 0. So I can try to solve the imaginary part first. So 4a plus 4i equals to 0i on the right hand side. So 4a plus 4 equals to 0. Therefore, your a equals to negative 1. When you get a equals to negative 1, of course, you can substitute it back into the real part here, where you should know that b minus 3a minus 18 also equals to 0. Okay, then substitute the value of a that you get here. Substitute it inside the equation. And by right, you will get the b, which is equals to 15. Okay, so this is how we get the value for a and b. So a equals to -1 and also b equals to 15. Alright, so this is our first part. Let's continue to part number B. Okay, for part number B, they want you to state the second complex root of this equation. Okay, so what's the second complex root? Our first complex root is this one, 1 plus 2i. And there's a rules that you should know that when we're having the polynomial, right, where all the coefficients are real number, so 2 is a real number, a is -1, which is a real number, 4 is a real number, b is 15, also a real number. So we're having all the coefficients inside the polynomial are real number, then the complex number root will appear in conjugate pair. So if I'm having 1 plus 2i is one root, so the conjugate pair of the other complex number, of the complex number will be the other root. So the other root will be 1 minus 2i. So this is the conjugate of 1 plus 2i, right? Okay, so 1 minus 2i will be the second complex root of this particular equation. So no special steps that you can show that. You just need to set out the answer. Okay, then how about for part C? Right, so for part C, they want you to find the real factors of the polynomial px. Okay, so to get the polynomial px, the real factor, the real number, some students might want to having trial and error. Okay, but for me, I think I want to use the complex root to help us to form the quadratic factor. Okay, before we can form the quadratic factor, I have root number 1, which is a complex root, 1 plus 2i. And then our root number 2 is actually 1 minus 2i, right? So I'm having two complex roots here. These two complex roots basically can form a quadratic factor. So how to form a quadratic equation by using the complex root here? There are many ways. So for me, I'm using the sum of roots, which is SOR, and also the product of root, which is POR. So what is the sum of roots? So the sum of roots means that you add all the roots together, the complex roots together, so you get the sum of roots. SOR, we call it S. Okay, so I'm having a 2 here. And then what about the product of roots? So the product of roots will be POR, where you multiply the two complex roots together. And if you try to expand everything here, right, so you're having 1 plus 4, which is equals to 5. Okay, so when you try to find out the SOR and POR, you can form the quadratic factor. Quadratic factor. So I think you learned all this in quadratic equation before, like how to form a quadratic equation by using two roots. Just that in our example here, the two roots are complex number, but the method are still the same. Okay, so to form the quadratic factor, the general formula will be x squared. Okay, so minus the SOR multiplied with x, and then plus POR, the product of roots. So I'm having x squared minus my SOR is 2, right? Sum of the root is 2. So I'm having x squared minus 2x. POR will be the product of roots, which is 5. So I'm having a quadratic factor, which is x squared minus 2x plus 5. So what is the purpose that we find out the quadratic factor? Because we know that the polynomial, okay, is built up by factors, right? When you're having one factor multiplied with the other factor, we will get a quadratic equation or quadratic expression. Alright, so we are going to do it the other way around. That means I want to use the quadratic factor and also the polynomial to find out the real factor that I have. Therefore, I have to apply long division. Okay, so I'm having x squared minus 2x plus 5. Okay, so something multiplied with x squared to get 2x power 3. So the something here should be 2x, right? So 2x power 3. 2x multiplied with negative 2x, I'm having negative 4x squared. Then 2x multiplied with 5, I get 10. Okay, then I take the term on top minus the term at the bottom. So when I take the term on top minus the term at the bottom will be 3x squared, then minus 6x plus 15. Then again, you ask yourself something multiply with x squared to get 3x squared. So the something here should be a 3. So 3x squared, then 3 multiply with negative 2x, I have negative 6x. And then 3 multiply with 5, then I have 15. So by right, you shouldn't have any remainder here after you take the term on top minus the term at the bottom. If you get some remainder here, that means something wrong with your quadratic factor or something wrong with your long division. Okay, so like this is my quadratic factor, and then definitely this one, 2x plus 3, will be my real factor. So I will write it here. The real factor basically equals to 2x plus 3. Okay, so this is what we have for part C. Alright, then let's continue to part D. Okay, so for part D, they want us to sketch on an Argand diagram and also shade the region that satisfying these two inequalities. So this is the first inequality and this is the second inequality. So for the first inequality, I'm having a modulus z minus u. U is actually 1 plus 2i, right? So I will substitute it straight away, 1 plus 2i. Then smaller equals to square root 5. Okay, so when you're having a modulus sign on the left-hand side and a value on the right, basically this kind of equation or inequality denotes a circle. Alright, so the shape will be a circle. Okay, so to make sure that you are having a very nice curve or maybe a very nice diagram, right? I would strongly suggest you to try and measure your diagram by using the same ratio for x and also the y-axis. So let's say for me, I'm having maybe 1 cm for 1 unit. So same thing happen for the y as well. So I think this one is a bit too wide, right? Okay, so let me adjust it a little bit. Okay, so let's say this is my 1, and then this is my 2, then 3, 4, 5. Okay, so when I'm drawing a circle, right, this inequality or this equation basically is a circle with a radius square root 5. Where's the center of the circle? Center of the circle will be 1, 2. Okay, so for 1 and 2, I will just plot it here. And then the radius should be square root 5. So you need to roughly count what is the length of the square root 5. And then you try to plot it maybe at the 4 points here. Okay, and then to form a circle. But there's one important thing that you need to aware, which is since the radius is square root 5, right? You should aware that from 0 to the point 1 and 2, okay, the length here is actually square root 5. Okay, which means that when you want to draw the circle for this particular curve, the circle must pass through the origin, which is the 0, 0. So all these are some small details that you need to be aware, all right, because they might not be hinting you on all this. All right, so you have to try to observe by yourself, and then you try to get all these details. Okay, so from 0, 0 to the center 1 and 2, the length is square root 5. So that means your circle will pass through this particular point here. Okay, so my circle, basically, if I try to plot them, right, it will be 2 point something, I think, if I'm not mistaken. And then here it will be somewhere like 4 point something. Then this one also like at this place, and then it will pass through a circle, and then this one will be somewhere here. Then if I want to sketch this diagram, right, the circle, it might look something like this. My circle might not be very, very nice. Okay, but I just want to emphasize that your particular circle here must pass through the origin. Okay, so I think my circle is not nice. So I try to draw it as nice as possible. Okay, one more time. So I will want to have a circle that pass through the origin. Something like this. Okay, it must pass through the origin. That's the main point, all right? So you might need to take some time to try and sketch it as nice as possible. Okay. Okay. So this is my circle. And then when they say smaller equals to square root 5, that means you have to shade the region inside the circle. But we have another inequality. Argument z smaller equals to pi over 4. So when I'm having argument z, right, I must take z minus 0 plus 0i, because this is a reference point that I want to sketch the line. Then smaller equals to pi over 4. Pi over 4 is 45 degrees. Okay, so what is the reference point that I want to take here? 0 plus 0i. So when you want to sketch a diagram, you need to take 0, 0 as a reference point. On the right-hand side of 0, 0, you need to measure 45 degrees, which is pi over 4. Okay, so from right-hand side line, the horizontal line on the right-hand side of 0, 0, sorry. Okay, the horizontal line, okay, from the origin 0, 0, you need to measure in anti-clockwise direction 45 degrees. So by right, you will pass through the point 1, 1 for 45 degrees. So maybe you can plot your point here, which is 1 and 1, right? Okay, pass through the 1 and 1. Then you draw a line going to this direction. Okay, so this purple color line will be actually argument of z minus 0 plus 0i equals to pi over 4. And in our equality here, they are saying that smaller than pi over 4. So smaller than pi over 4 means that it will be the angle, will be the area below the line. Okay, because like what I know, this is the 45 units of pi over 4. So smaller than pi over 4 means all the area below the line will be smaller than pi over 4. All the area below this line. Okay, below this line. Okay, all right. So if you try to observe, just now we sketched the area inside the circle, and now I want to shade the area below the line. Therefore, the overlapping area should be this here, this area here. Okay, so this is actually the intersection area that fulfill the inequality. Okay, the two inequalities shown in the question. Alright, so this is the diagram that we have. So if you want, don't forget to label it again. For Argand diagram, we are having x-axis is real part, and then the y-axis will be the imaginary part. Okay, then next one. Find the least value of imaginary part of z. So when you talk about imaginary part of z, that means what? That means the y. Because I'm having x plus yi as a complex number, right? So this one we call as the real part of z. That means the real part of a complex number z. And the imaginary part will be the y only. So they are looking for the y. Smallest y. This value means smallest, the smallest value of y for the points in the shaded region, and they want you to give the answer in exact form. So where's the smallest point? Okay, the lowest point of y. So in your diagram, right, where's the lowest point of the y? In the whole shaded area, this is the lowest point. Okay, so this is the lowest point. So how can I get the value of this lowest point here? Okay, so basically it's like this. You can see that we are having this whole thing as 2 unit, right? Okay, so this whole thing is a 2 unit. And then this point is basically square root 5, because in a circle, in this circle, I know that the radius is square root 5. I know that this area, the length here, the vertical line, the length of the vertical line, or maybe the length of the radius is a circle. For this circle is square root 5. And then the center is having the value y. Therefore, from the center, which is the y equals to 2, go down to the lowest point here, the value should be taking 2 minus square root 5. That's it. Okay, because it is square root 5 units below the 2. Therefore, the exact value for the least value of the imaginary z will be 2 minus square root 5. Okay, and usually for this kind of question, you might need to refer to the diagram that you draw and also the area that you sketch. So it will be good if, let's say, your diagram can sketch as clear as possible, so that it won't be misleading when you are trying to find out any values about the z, okay, from your diagram. All right, so this is how we answer the question number 10, and we have completed all the questions in this paper. Right, so thank you very much for watching this video.